Here we have an inequality, 1 over square root of absolute value of x plus 1 minus 2 less or equal than 1 over 9 plus x. And we need to find such x that satisfy this condition. So first of all, notice that square root sitting here in denominator has to be positive. In general, square root is non-negative, but because it's in denominator, it cannot be 0. So it's strictly greater than 0. But since the right-hand side is greater or equal than left-hand side, and left-hand side is greater than 0, it means that the right-hand side is greater than 0, which means that denominator is greater than 0, which means that x is greater than minus 1. So the next thing to notice that whatever's inside of square root has to be positive. And if you want to find x that satisfies this condition, we need to solve this inequality. And to solve it, first of all, we need to figure out what the absolute value is. And by definition, absolute value of some number z is z itself if z is non-negative, and it's minus z if z is less than 0. And the way you solve any inequality that involves absolute value is to use this formula. And what it means in our case is consider a case when x plus 1, whatever's inside of absolute value, is non-negative. In this case, absolute value of x plus 1 becomes simply x plus 1. Okay? And in this case, we get inequality of this type, which means that x is greater than 1. The other possibility is when x plus 1 is less than 0. In this case, absolute value of x plus 1 becomes minus x plus 1 based on this formula. And now if we put minus x plus 1 instead of absolute value of x plus 1 into this inequality, this is what we're going to get. And we simplify that and we get x less than minus 3. So what we see now, that this inequality we're looking at here is satisfied when x either greater than 1 or less than minus 3. We also need to remember that x has to be greater than minus 9. Because denominator on the left-hand side and denominator on the right-hand side are both positive, it means that if we multiply by 9 plus x and by square root of this quantity, both hand side of this inequality is not going to change. So if we do that, we're going to get inequality like this. The next thing we're going to do is we would like to square left-hand side and right-hand side. And we can do that because if I have a value a and a value b, such that a is less than b, but a itself is non-negative, in this case, if I square a and b, inequality will still stay. So now, if I square both left-hand side and right-hand side, I'm going to get an inequality of this type. Okay? What you have on the left is 9 plus x squared. The next thing we're going to do, we're going to move everything to the left-hand side. If we do, this is an inequality we have. And again, to solve this inequality, we actually have to open up the absolute value. And we are going to open it up by first considering x plus 1 greater or equal than 0, and then x plus 1 less than 0. When x plus 1 is greater than 0, then x plus 1 inside of absolute value becomes x plus 1. And we get inequality like this, which we can simplify by getting inequality of this type. Now, to continue, what we need to do is to remember the following fact from quadratic functions. So any quadratic function like ax squared plus bx plus c, where a, b, and c are some constants, can be written as a times x minus x1 times x minus x2, where x1 and x2 are roots of quadratic equation ax squared plus bx plus c, and those roots can be easily obtained using this formula. Okay. Now, in our case, a will be 1, b will be 17, and c will be 82. Now, if you plug those values here, what you're going to have is we're going to have a negative number inside of square root. This particular polynomial does not have any real roots. And that means that either whole polynomial is positive or whole polynomial is negative for any value of x. Now, to figure out which one is true, we need to look at the coefficient in front of x squared. If that coefficient is positive, whole thing is positive. If that thing here is negative, the whole thing is negative. As we see, the coefficient in front of x squared is 1, it's positive. It means that for any x, this quadratic function is positive, which means this inequality has no solutions. Let's consider the other case when x plus 1 is less than 0. In this case, we're going to replace x plus 1 in absolute value as minus x plus 1. So we take minus x plus 1 and plug right here. So what we're going to get is an inequality of this type. And again, simplify that, we get another quadratic equation. So what we're going to do now, we're going to use this formula that we have here. And when we find that this formula gives us this expression. So what we see here is we have two factors, product of two factors, which should be less or equal than 0. That is possible when either the first factor less or equal than 0 and the second factor is greater or equal than 0, or when the first factor is greater or equal than 0 and the second factor is less or equal than 0. So what we find in this case, if we're saying that the first parenthesis should be less or equal than 0, it means that x is less than or equal than minus 12. What's going to happen in this case, the second parenthesis is going to be negative. So we cannot have the first parenthesis less or equal than 0 and have the second parenthesis greater or equal than 0. That doesn't work. So what works is the other way around. When the second parenthesis is less or equal than 0, in this case x is less or equal than minus 7, and the second parenthesis is greater or equal than 0, in this case x is greater or equal than minus 12. To satisfy both conditions, we have to have x in the range from minus 12 to minus 7. Now what we need to do, we need to really look up and find that x is actually has to be greater than minus 9. Also, when we consider this case, we need to notice that x should be less than minus 3. And to satisfy this, this, and this at the same time, we find that x has to be strictly greater than minus 9 and less or equal than minus 7. And that's the final answer. My final thought is, if you remember, we derived these two conditions over here from the fact that whatever's inside of square root is positive. But in reality, we didn't have to spend time doing that because those conditions were satisfied automatically. And that's because of this inequality. What you have on the left is 9 plus x squared. And by design, that thing cannot be negative. So when we solve this inequality, whatever we have on the right-hand side cannot be negative. Okay? And we also said that what we have on the right cannot be 0 either, but that condition is satisfied right here. if x is greater than -9, whatever's on the right is not 0. So really, these two conditions, all the time we spent here, wasn't necessary. And those conditions are automatically satisfied if we take into account this condition. And that's about it.